Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases. Welcome to episode 6 of Solution Architect Associate Exam Question Series. We'll cover questions 26 to 30 in this episode. For questions 1 to 25, please refer to previous episodes of this series. Let's get started. Amazon Redshift is being used by a business to do analytics and produce customer reports. The corporation has just obtained an extra 50 terabytes of demographic data on its customers. The data is saved in Amazon S3.csv files. Organization needs a system that efficiently merges data and visualizes the finding. What recommendation should a solution architect make to satisfy these requirements? So what we have here is there's an organization and they're using Amazon Redshift for data warehousing. So that's our current understanding of the problem. There is a reporting application. We are treating it as a empty box right now because we don't know. And the organization wants a solution for reporting and visualization. On top of it, they have an added complexity. The organization has recently obtained an extra 50 terabytes of demographic data on its customers, and that data needs to be merged as well as part of the reporting. So you have data in Redshift and you have data in S3. Both needs to be merged in a solution. So what we need to do is data in Redshift, data in S3, this added data, all of this needs to be merged, or the queries have to run on it. And then we need to create the reports and put it in visualization tool. This is our problem. That's what we want to solve. Now, what's our solution? So in this case, we have multiple options here. It could be Amazon Athena could work on this data for analytics, or it could be Redshift itself, where we can load all of this data in Redshift and then do the queries on Redshift, or we could use EMR, or there's one more option, which is Redshift Spectrum. For reporting, I think it's very clear. Amazon QuickSight is the preferred choice as far as AWS is concerned from visualization perspective. So wherever you see visualization, your first choice should be QuickSight because that's the cheapest, easy to integrate solution with most of the AWS technologies. Now let's look at all these 4 analytics options in detail. So the first one, Athena. Now Athena is a very good solution. It offers a console where you can query on S3 data with standard SQL and no infrastructure to manage. So this is ideally a best choice if you're just dealing with S3. However, the problem we have is we don't just have S3. We need to join the data with Redshift, and that could be cumbersome. If it was just S3 data, my preferred solution would have been run the queries in Athena and do the visualization in QuickSight. And we'll compare this option in much more detail later on as well. But Athena only charges per query time use. So it's a very economical situation as well from that perspective. The second option we saw was Redshift. Now Redshift is good. You can load data from S3 in Redshift cluster and do the analysis. However, as you can see here, it's going to be a significant storage space needed. You need to do the loading, and it's a costlier option. Redshift itself is a costlier option. On top of that, we are now adding more data to it, and that loading process is also going to involve some cost. Another option, EMR, this is the costliest option. It uses Hadoop style queries to access and process large data sets in S3. This is the costliest option. I would never go for EMR for any of the AWS exam question because it's always one of the costliest options available. And the last one is Redshift Spectrum. Now, Redshift Spectrum is a best of both worlds situation here. It seamlessly joins data from S3 and existing Redshift table. So you don't need to load data in Redshift. Spectrum can directly work on S3 and it can do analytics queries. And the cost-wise, it's a very low-cost solution. And in this scenario where you already got some data in Redshift and then outside in S3, this is the perfect solution. Our solution landscape will look like this. All of these options will disappear, and the winner is Redshift Spectrum. That should be our solution in this case. Redshift and Amazon S3 using Redshift Spectrum, you can query directly here. There is no actual loading required. And then you're reporting in QuickSight. This is your overall solution. Let's look at just the benefits of this solution, Redshift Spectrum and QuickSight. The RS Spectrum feature allows querying large data set directly in Amazon S3. And this is most important aspect. It's directly in Amazon S3 without any need for loading the data in Redshift. So this is the aspect why we have gone with this option. There could be other scenarios where you have no Redshift present and it's just data in S3. I would go for Athena as I told you earlier. So that's Redshift Spectrum. That's the advantage of it. Joining data, again, it's an extension of the same problem, which is Redshift Spectrum seamlessly joins data from S3 with existing Redshift tables, and you don't need to load data anywhere. And QuickSight, as we know, is the best visualization tool available. It integrates perfectly with Redshift. This is overall analysis of the chosen option. Now let's jump into our question landscape and quickly run through these options, select the correct one and eliminate and give justification based on what we have discussed in last few slides. So option A is the winner, obviously. That's the chosen option. We have discussed this in detail. Option 2, which is option B, Amazon Athena. In this case, it's not better than option A, where RS Spectrum can actually query on data, S3 data, which is, and then combine it with Redshift. So it loses out to that. The third one, which we have also discussed, that one, Redshift's cluster. You don't need this option. It's very costly. In fact, this option also is talking about EMR. So two costly options there. Absolutely no. The fourth option, we have not discussed this, but this approach would consume significant storage space. We are using multiple services here, S3, Elasticsearch, Kibana. Absolutely, it's not a correct option. First of all, select the service that is made for a particular scenario so that you don't have to use multiple services. Yeah, and then obviously next one, don't use unnecessary number of services, because more services means additional cost. And here we are on top of Redshift. We are doing a lot of analysis and loading and involving multiple services. So this is an incorrect option. So our final answer is option A, which is Redshift Spectrum and QuickSight. Question number 27, another question on data analytics and visualization. Each month, a business keeps 200 GB of data on Amazon S3. At the conclusion of each month, the corporation must analyze this data to calculate the number of things sold in each sales area during the preceding month. Which analytics approach is the most cost-effective option for the business? So what do we have here? Let's analyze the problem, understand overall problem description. So we have 200 GB of data on Amazon S3. That's our starting position. And we need a solution, an analytic solution and a visualization solution for this problem. So it's not a complex situation. Data is in S3 and we have just discussed various options of analyzing ETL, analyzing and visualization. So let's see what fits in this particular case. So essentially we need an ETL plus analytics tool here and visualization here. So in case of first, you have all of this data in S3. You need to first extract, transform, and load. You need an ETL tool, and the best ETL tool from AWS for this job is AWS Glue. So you need that. So that would take all of the S3 data and it will load it. Then you need an analytics tool, and the best solution in this situation is Amazon Athena. Athena provides a console, as we have discussed in previous example, where it can run on S3 data after AWS Glue has done the ETL job, and then it seamlessly integrates with QuickSight, and you can do your visualization on the QuickSight. So this is a very standard scenario where you have data in S3 and you need to use that data to analytics and reporting. This solution you can use anytime, any place. So that's the overall solution. For ETL, you use AWS Glue Catalog. For analytics, you have Athena, and for visualization is QuickSight. This is a very standard solution. So if you see any problem which involves extraction, ETL, transform, load, analytics, and reporting on S3 in any type of data format, then you can always go for this combination. This is the cheapest, cost-effective solution for reporting. So let's look at this option a bit more in detail across all the advantages this provides. So the first one is cost effectiveness. This approach minimizes cost across several aspects. On storage, you are using S3 storage, that means you're not needing EMR or Redshift, anything else. So that remains cost effective. Another aspect of cost effective and compute is you're using Athena as the tool for analytics. Athena charges only for the data scanned, making it an ideal solution for infrequent analysis like this monthly requirement. Management, there is no need to manage any dedicated clusters of EMR or Redshift, so there is no operational overhead here. And suitability for the task. So in this case, we are saying we have 200 GB of monthly data, and it doesn't necessitate the power of Redshift or the real-time capabilities of Elasticsearch. So Athena can handle efficiently this particular scale for ad hoc queries. In fact, in the environment I work, most of the data lake analysis is done by Athena, plugging in data in QuickSight. So this is one of the most preferred tool for any sort of ad hoc monthly, weekly reporting query. The final one over here is visualization. So QuickSight is the preferred choice. QuickSight seamlessly integrates with Athena and also with other AWS tools. In fact, this solution is your template solution for many scenarios involving data analysis of various data files on S3. With that super detailed analysis, let's jump to our final section of analysis and select the options which are correct here. So let's eliminate first from here. I would definitely eliminate the last one. It's a super costly option. The data is in S3 and we're talking about loading it in a Redshift cluster. That's there is no need for it. Athena can do the job. You don't have to load data in Redshift. It's going to be a very costly solution. So D is gone for that reason. So the next one, option C, using of EMR. This particular option is also not correct. Unnecessarily, you are using EMR clusters. It adds complexity, and it's an infrequent use case. You are doing this once in a month, so this is not necessary. It's a costly solution for this. It will work, but it's an expensive solution. We need a cost-effective solution, and in most of the reporting solutions, you will have this requirement. In fact, for all the options by default, having for all the questions across AWS examinations, using a cost-effective solution is implicit, and option C is wrong. The next one, again, we have in option A, another costly solution. It's using Elasticsearch service, and for visualizing, it's using Kibana. The main problem here is using Elasticsearch service. You can use it for real-time searches, and if you have large-scale log analysis, it's an overkill scenario in case of this ad hoc requirement of doing monthly reporting. So not needed. So option A is also gone because of cost effectiveness being an issue over here. Final option, which is option B, which we have discussed at length, is the correct one. Use AWS Glue Catalog for ETL, load the data using that service, then use Amazon Athena for querying, and you can do visualization in QuickSight. You can see here the second part of this problem on the right-hand side. AWS Glue crawlers are running on Amazon S3 using Glue Catalog, and then query engine is Amazon Athena, and Amazon QuickSight is your solution. So this is one sample of applying well-architected framework for doing analytics and reporting using Athena and QuickSight. That's it on this question. Let's move on to the next question. Question number 28. A business's data layer is powered by Amazon RDS for Postgres SQL. The organization must adopt database password rotation. Which option satisfies this criteria with least amount of operational overhead? So this is a security related question, and there is a lot of information. So let's understand the problem description here. They have mentioned about RDS and Postgres SQL database, but the real keyword here is password rotation, and that's about it. It doesn't matter which service we're talking about. The overall problem description is about if you have to do database password rotation, what is your least operational overhead for managing password? There is a service in AWS for it, and it's a purpose-built service. And in order to keep the operational overhead low, you should use automatic password rotation. And that's as simple as that. And we can see that option here already. But we will eliminate the wrong options, and I'll give you the reasoning for that. And then we'll go to our correct option. The option B is wrong. It will support password storage, but it lacks built-in automatic rotation facility for RDS databases. So you need to write a custom code or script for rotation, increasing complexity and overhead. So anything that involves scripts, custom, trying to do a job of a service that already exists, it's a no-no because you are doing multi-step operations. So option B is wrong. You cannot store the password in system parameter manager because it doesn't support automatic rotation. So we rule that out. Then another wrong one for me is the next ones. Option C, it's again a similar solution of using AWS System Manager Parameter Store. And it is saying now use Lambda function for rotation of the password. So you're basically again writing custom scripts for doing this job for rotation of the password, which is a strict no-no. It doesn't matter. It is Lambda function. It's serverless. You don't need it. This service is not built for storing passwords and doing an automatic rotation of the password. So it's a wrong option. The next one is KMS, option D. So option D says, let's use KMS for storing password. It is not for password storage. It is for key management. It's a key management service. That's what its purpose is. For storing password, you have another service, and that's what we are going to go for. This particular service cannot store the password, cannot encrypt, cannot offer automatic rotation of password. So definitely a wrong option altogether. So B, C, D, all are wrong. The correct answer for this is AWS Secret Manager, and you have to enable automatic rotation on for the secret. So that will do automatic rotation, and this is your correct option. I have listed here all the features of this option. So as we have seen, it does automatic rotation. Secret Manager takes care of rotating the password on schedule. It eliminates the manual task and obviously any risk of human error because everything is automatic. It's a secure storage. Secret Manager stores the password securely using encryption and access controls, ensuring the sensitive data stays protected. So it's secure. Integration with RDS, I think that's a feature here. It natively integrates with Amazon RDS for PostgreSQL, allowing it to automatically update the database password when rotated, minimizing any downtime or disruption. So that's a key one here in terms of this particular problem scenario. And another important thing, it also has auditing and logging. Secret Manager provides detailed logging of auditing of password, access rotation events, etc. So in case you have to go back and check for compliance purpose, who all accessed the passwords or changed it, you have that audit trail. So perfect solution. Let's look at AWS Secret Manager, AWS documentation as well. I've already gone over various aspects of it as part of the previous slide, but here is a page from AWS documentation, and I'll provide a link for this in video description. There's a short video here. You can watch that video as well to understand a bit more about AWS Secret Manager. From exam perspective, wherever you see a use case of managing password with automatic rotation, you should simply go for AWS Secret Manager. And there is one more article from AWS documentation of around how to set up automatic rotation for any passwords that are stored in AWS Secret Manager. You can go through this as well just for reconfirming your answer. That's it on this question. Let's move on to the next question.
Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you.
Question number 29. A business's production workload is hosted on Amazon Aurora MySQL DB cluster comprised of 6 Aurora replicas. The corporation wishes to automate the distribution of near real-time reporting requests from one of its departments among 3 Aurora replicas. These 3 copies are configured differently from the rest of the DB cluster in terms of computation and memory. Which solution satisfies these criteria? What do we have here in terms of problem description? There is an Aurora MySQL DB cluster, and it has 6 replicas. 3 of the replicas are configured differently. They are optimized for usage. And what the corporation wants to do is there are some near real-time reporting requests coming from one of the departments. So they want to route all of those requests to a set of replicas out of these 3. Now, this is a very specific topic in terms of Aurora endpoints and a usage of certain endpoint for this exact use case. So I would like to take you to an article from AWS, which talks about this exact scenario. This is a very specific case of Aurora workload management with different types of endpoints. But as you can see, this was posted in end of 2018. So this is when probably the feature was launched. As you can see, it says you can now create custom endpoints for Amazon Aurora databases. This allows you to distribute and load balance workload across different sets of database instances in your Aurora cluster. For example, you may provision a set of Aurora replicas to use an instance type with higher memory capacity in order to run an analytics workload. A custom endpoint can then help you route the analytics workload to the appropriately configured instance while keeping the other instances in your cluster isolated from this workload. As you add or remove the instances from the custom endpoint to match your workload, the endpoint helps spread the load around. So this is the exact scenario that we have, and we will go to our question and the options. But before that, I would like you to also look at different types of endpoints. I won't go through all of this in detail, but I'll give you links for this in video description. There are typically 4 types of endpoints: cluster, reader, custom, and instances. And you will see these referenced in our question as well. And there's one more article. Again, you will get the link for this in a video description, which is how do you use custom endpoints. With that discussion, let's come back to our question. I will probably create a separate short video to go over endpoints, but from exam perspective, we're covering what is needed right now, which is the custom endpoints. And as you can see, there are 4 options here. Custom endpoint is one of them. Then there is a cluster no endpoint, renode cluster clone. And we are talking about instance endpoint and then reader endpoint. All the 4 endpoints that we saw in the previous article from AWS documentation are here. So let's look at the obvious wrong one. So option D appears to be the obvious wrong one for me. It is about reader endpoint. Now, the standard reader endpoint distributes traffic across all available read replicas, not allowing selective targeting of specific three replicas with different configuration. So reader endpoint, what it does is whatever replicas you have, it will just distribute the load across all of them to load balance. So if suppose you have, in this case, six read replicas, and if you create a reader endpoint and you get reporting application request, then it will distribute across each of those, each of the DB instance depending on which is not heavily loaded. So just to load balance all the requests. But what we want here is we are trying to send near real time reporting requests to a specific sets of DB instances, and that's not possible using this. So with this particular option, we won't be able to route the traffic, read traffic to the three copies which are configured differently from the rest of the DB cluster. So that's wrong. The next one wrong for me is C. It's about use of any instance endpoint for selected three nodes. Using instance endpoints manually would require application changes and wouldn't provide automatic load balancing or failover. The whole point we want is we want to create endpoints, but we also want automatic load balancing. Whenever the disaster happens, we want some sort of failover there as a, like out of the three DBs we are interested replicas. If one of them goes, we want automatic failover also and with continuity of the service. So this is not going to achieve that. So that's wrong. So option C is incorrect. Then the last incorrect, obviously D, it says create a three node cluster clone and use the reader endpoint. Creating a separate cluster again adds complexity and cost, and it might not even guarantee consistent data synchronization with the primary cluster. You already have a cluster of six because now you're saying you create another cluster of three separately. It's a incorrect option. And that leaves us with our already pre-selected option, which is option A. We will use custom endpoint to route traffic to specific optimized replicas of databases. And it will also do automatic load balancing to distribute reads evenly across these replicas, and it will maximize the performance and resource usage. So that's the correct answer for this particular question. Let's move on to the next question. Question number 30, a business's on-premises data center has reached its storage limit. The organization wishes to shift its storage system to AWS while keeping the bandwidth cost as low as possible. The solution must enable rapid and cost-free data retrieval. How are these stipulations to be met? So what we have here in terms of overall problem description, we have corporation and it has a data center on-prem. So on the left-hand side, we have here is the on-prem data center and the storage that it is using, the storage limit has reached. So that's the problem we have. Organization wants to shift its storage to AWS. They want to keep the bandwidth cost as low as possible and want rapid and cost-free data retrieval. Final destination for the storage, I'm assuming, because that's an obvious choice, is some sort of Amazon S3 tier. And we don't know how we are going to achieve it. So we have an empty box here. But let's see how we can solve this. So we're starting with our problem of storage is full. So we have this problem that you're sitting in on-prem scenario and you need to extend your storage capacity to AWS. And the obvious choice for that, and we have done this in previous episodes as well, is storage gateway. So storage gateway can provide you a solution for extending your on-prem storage into virtually unlimited cloud storage, which is pointing to S3. And this is how that solution would look like. Now, this is not the complete answer, but this is your typical scenario of whenever you have an on-prem to AWS storage requirement, storage gateway is your best option. The storage gateway itself does not have storage available. However, it points to S3. Don't worry about the middle part of this equation. This is for completeness of the solution. Focus on storage gateway and S3 as your key parts of the solution. So that we have here. But if you look at the options, you will understand this is not the final answer. We still need to determine a few other parameters of the overall solution. So we'll look at the options and then we'll come to the final answer. Let's look at this option. I have highlighted our keywords, which we discussed on the problem description, but the solution storage gateway, you can say our storage gateway is in option B, C, and D. So it appears 3 times and it's not in A. So let's look at option A first, eliminate that, and then we'll select the right option from remaining 3. So the first option says deploy Amazon S3 Glacier Vault and enable expedited retrieval. Now, this is okay and cost effective in long-term archival, but data retrieval is going to be slow and it will be charged separately. Now, what we need here, if you see the requirements here, we need rapid and cost-free data retrieval. Now, both the requirements are not going to be fulfilled. So on that I'm not saying this could be otherwise a great solution, but from an elimination perspective, I can just eliminate this option because we need rapid and cost-free data retrieval, and this option doesn't provide. So that's gone. Now we have three options here, and all of them having AWS storage gateway. Now, what you need to understand is our on-prem storage is already full. Any option that says we need to store data locally cannot work because your data is storage is already full. If you're using any solution which then again tries to store data locally, there is no space there to store anything more. So if you look at option C and then option D, both of them they're talking about let's use stored volumes to store data locally. And even option D says AWS storage gateway, but store the data locally. Now, in both the scenarios, you do not have enough space to store the data locally. So that's these two you can rule out straight away because of that. And then if you look at then what is left is option B, which is obviously storage gateway again, but it's saying let's use cache volume. Now with cache volumes, the first retrieval will happen at the storage gateway itself. So if there is any request coming from on-prem, it will look at the storage gateway first. It will look at the cache volume. And if the data is found over there, it won't go all the way to S3. It will minimize the S3 tips and it will reduce the bandwidth cost as well. So cache volume provides you the solution for minimizing bandwidth cost as well as overall cost of the solution. And with cache, obviously the retrieval of the data or objects would be pretty fast. And overall, the solution will work better. So that's our answer. This is a pretty complicated question. Obviously, is the storage gateway part of this particular answer selection is pretty straightforward. But then when you come to the eliminating other options from cache volume versus local storage, I think it becomes a slightly complicated conversation. But you've seen how we have eliminated the wrong options and selected the correct answer. So that's our final answer, option B, use storage gateway with cached volumes. You can see how cache volume can be used for retaining the frequently accessed data and then how that minimizes need for scaling your on-premises storage. And it also provides low latency access for your frequently accessed data. So very important concept. Please go through it. That's it on this question. And I believe this is the last question of this particular episode. I'll see you in the next episode of this series soon. Thank you. This is Exam Tricks and Tips. You're watching AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.